All right, before we get into the meeting at hand, let's go over this month's Python pop quiz brought to you by Mike Driscoll. Number 39, so we're reaching back. List of functions. We're starting this thing off with a list and we're naming it functions. And then for whatever reason, we're getting into a for loop where we're iterating through a range of variables or integers on the value number. And then we
Mhm.
have a nested function, which only returns the number. After that, we're appending a function, that function to the list functions. And then outside all of that, we're doing a list comprehension. Results equals function with paren, which I think is something we need to kind of focus on in this one,
Mhm.
in addition to just list comprehensions in general. And then the rest of that list comprehension for function and function. So presumably we've got functions, that thing we defined at the beginning is full. We're
Mhm.
iterating through its list of items, and then we are calling them as functions in the results. And so then we are going on to present or to print whatever results is. So do we have any guesses as to what the output is going to look like? Are we going to get a list of function objects since we're saying function open close paren? Or are we going to get 1 through 8 because this is a number range problem potentially, or 0 through 7 because we're smart Pythonistas and we always start with 0, not 1? Or is it 777 for the jackpot or all eights? Any any guesses there?
The list of seven sevens.
Robert
Mhm.
says it's a jackpot.
Yeah, that's well, I ran it, so
Yeah.
Yeah, well, yeah, I guess the code doesn't lie.
The,
All right, well, let's.
it's hard to read the second thing I posted. You need to actually click on it, but that actually explains exactly what happened.
Nice. All right, well, let's give her a go. Assuming I typed this in right.
hmm
And Robert is right. Once again, I think Robert's batting 1,000 on these. No wonder he wins hackathons. 77777. Okay,
Yeah.
so let's talk a little bit about that. And of course, the time for the graybeards in the group to gripe about how we would never do anything like this in code. But all right, so this list here that we're creating, we're iterating over it in this thing right here, which is called a list comprehension. So a list comprehension is a convenient way of generating an iterable, and it uses basically the syntax of a for loop and then assigns some output, and the output is an iterable based on that initial one, and in this case, stored into results. So functions is what exactly? We've gone through here and appended a whole bunch of just my function, which apparently it seems is going to be agnostic of any actual value, perhaps, or will it? I don't know. I guess
Uh,
each time we're going to be generating a
yeah. What
new,
do you,
yeah,
the first thing that I notice is that when you look at my function, it says return number, right?
right,
So that means that what you get back from calling function will be a number, right?
right,
You just don't know which numbers yet. Um, but the second thing is that there's a closure in there, right? Because it says for number in range, and then when you define my function, nothing is actually passed to it.
right, right. So
Um,
we've got this local value of number inside the function thing. And then I guess it's just going to be whatever the last value of range was or of number was as we went through that range. And
Mm.
so every time we iterate through this, and we should get 8 values, I guess, 0 through 7.
Mm-hmm.
So, but basically we should just get 8 my functions appended to this list functions, right? And then I guess the thing is, if you've given the name of a function to like the value of an iterable, you can later call it by saying that value with the paren. What is that called?
The value with the parens?
Yeah, so the basically this list is
That's
just going to have a whole bunch of my function in every single value, right? And so then later
no.
you can say, oh, hey, Deanne.
Hi. Sorry, I was doing something else. So apologies if you mentioned my name earlier. But I did put this into
Okay,
Python
this is
Tutor
good.
for you, which you might like to try out. But
Hmm.
to answer your question, my function by itself is the name of a function. So it
Right,
stands for the function. So it is an object.
right,
Whereas a couple of lines later, function with parentheses, you are executing whatever function is. And of course, we're getting function from the list comprehension. So
right.
it's each one of those. Um, let's start again. When you build the functions list using the for loop, you are creating a list which consists of a series of function objects.
Right.
Now that's the object. Now in the last line, because we have the parentheses, we take the object and we execute it.
Right. So that only
Right?
works if you're storing a function object.
Correct.
Otherwise, this will cause some sort of
Or
error.
or or a, or a class which can be called.
Oh, okay.
So it has to be a callable to use the proper words. Yes.
All right. So then, because we have iterated through this range, so 0 through 7, we've then created 8 values, and all of them are my function. But I guess most importantly, the value of number remains in the local space as 7 or something. That's why we end up with 7 as every single value. If you've got, did you say you
Uh,
have
uh,
Python tutor
no.
up?
Yes, I did. At the end of the loop, right? So you got four number in range 8. At the end
Right.
of the loop, when you drop out the bottom of that loop, number's going to be 7, isn't it? It's going to be the last value that,
Right.
that was executed in the for loop. So that's why when you execute function on the results equals line, uh, uh, number is taken to be 7
Oh,
exclusively.
I'd like to you to try something interesting.
okay.
Uh, Set number, like first print number, just type in number, or you could do it. Now try number equals 8 and see what results does. Oh, do run the results function again and print out what results is.
Yep. There it is.
Huh. Yes. So I want you to do something like results, you bracket 0. The first element of the results, list.
Right.
Oh, sorry, functions. Put in function 0 and put in functions 1. So they're oh,
Yeah, they're different objects.
they are different objects. I have functions too. Oh, that's interesting. Thought they were the same object.
So they're different objects, but yet they were initialized with the same number object, right?
Well, this is interesting. On my machine, looks like they've got the same address and memories. So let me see. So,
Okay, so if you think object oriented for a moment, you're effectively instantiating the function, and that's why you get different IDs. They are the same code within the function, but they are different instances of the function. Now, the instance of the function doesn't have a name, so it's not like instantiating a class where you have a class name, and then you would have, with in this case, 8 instances of the class, each of which would have to have its own name or be kept in a collection. All right, so that's why. But that's a very good observation, Tanim. Hadn't thought of it like that.
Huh.
So that has a bearing on your storage space, right? If it was a large function or you had a large number of instances of that function in the list, you would have to think about that. Nicely spotted. Yeah, well done.
Well, this is why I don't like comp sci. It's not completely clear. This is a lot of in practical terms, this is ugly code, which if I understand how it works, it's just going to give me a headache because it's confusing. Like
Right.
the scope of variables, um, associated with this function is unclear.
Yeah, because it's nested in a for loop, and then
Yeah, exactly.
yeah.
The
But I
Well,
guess
scope
the
of
as
scope of number is
nested
outside
function
of
is really unclear to me.
right.
as Robert said, it's a closure. So if you've got a code like that, you're going to have to live with it, mate.
Yeah. So so when I ran this through Claude, it gave a recommendation for the right way to do it, right? And so it says the right way to do it is you actually do pass it as a value into the function, and that way, uh, and
Hmm.
that way the number is bound earlier. But by leaving the parameter list for the function empty, then you get this weird behavior where it's late bound, and of course, um, the when you by only evaluating it when you get to the end of that list, then everything's going to be that last number.
Right.
Yeah, so it's useful if you want lazy or late execution. But as you point out, and probably the source of Tanim's confusion is we would much rather say we're going to deal with this function, so process it now and give me the output, rather than what he's actually doing here. The array called functions is actually a pipeline, because when you come down to results, you're actually executing a whole series of functions one after the other.
Yeah, so he's showing you how if you're not paying attention, you can fall into a trap and get these weird results, right? But it's
Yep. Yep.
he's demonstrating worst practices instead of best practices.
Yeah, what's the
And
opposite of in a
yeah,
corner case?
a good reason not to show people, but yeah, but as you say, a good reason to show people so that you realize, hey, there's here be dragons.
All right. Well, humor before we got kicked off tonight.
I like that.
Do this not because it is easy, but because we thought it would be easy.
Yep.
It's not easy. No. All right. Welcome everyone to March 6, 2025, third meeting of SacPy
Yeah,
on
this year.
Zoom. Welcome back, everyone. Our return guest, Saurav Saha from NEC in Japan, talking to us again about FireDucks. As you may know, FireDucks is a drop-in replacement for Pandas and makes things go extra fast. And as it turns out, Tanim says it's easy to install, and let me tell you, that guy is hard to impress. So that's major props there. But Saurav, welcome it back once again. I'm going to hand the share off to you. Thanks again for coming.
Thank you. Thank you so much, Uday. Okay, so let me share my screen. I think it's visible. Okay. Okay, thank you for the wonderful discussion previously, actually, on this functions and list of things. So it's kind of, I'm not sure how good to follow, but it's kind of difficult to practice in the real development. So this kind of information is good to have. Really, thank you for that. Okay, so to start with my presentation today, I believe the last when it was around July last year, I think. So I had a presentation at your platform on FireDucks. So that time we just have developed it and did some benchmark, talked about it, explained its features. So today, probably if any of you have used it, want to share some feedback, so that is more welcome. I'd love to interact on that. Other than that, I would love to discuss the recent development that we had made and the features and the benefits that it offers. So yes, so with that, my presentation will be something like we'll unveil the execution benefit of FireDucks, which is a data frame library with a JIT compiler. So the agenda will be something like this. I'll be talking about Pandas with some tips and tricks that include some quizzes. After that, a simple introduction of FireDucks, its offering, benchmark, and some hands-on. Okay, so I believe this is the same slide that I used last time just to give you an intro. Like this is the usual flow of the data scientist that you follow. We collect data from different raw resources, clean it, give it a new shape, make it ready for the machine learning, and then do training. And after the training, we do the deploy and everything. But this is an iterative cycle. The better the data, the better the model. That is the concept that you follow. So data preparation is ideally taking a lot of time because finding the good insights out of the data is really challenging, and it's always taking the time as per the research. Like around 75% of the time is being spent in this data loading, cleaning, visualization kind of stuff. So what is most popular in this area, as you all can understand, that Pandas is something that you all have learned and talk about. Even today, it has 100 billion plus downloads over the month. So it is, of course, that famous, and I believe it is here in the market since 2008. But the time when it was developed, there was no concept of the big data because it was ideally for the Python user who love to explore the data. So it was kind of having problem. It is kind of having a problem when you try to use it for the production level code. For example, when your data goes larger, when you are working on the cloud side and all. So why so? Because first of all, most of its operation single threaded. Because of that, it is getting much execution time when you're running for a larger data and have to wait for a single simulation to single simulation to finish. If you're running on the cloud side, you're paying a lot of cloud costs at the end of the month. That is the current pain of many companies, many enterprises. And of course, it's not eco-friendly because longer running time will attribute to much carbon dioxides. So this is the current thing that a user kind of when you are thinking of pandas to use in the production level or for the larger data processing, people are usually bothered of that particular facts. So there are many alternatives, although that try to solve these kind of problems. But today I'll be talking about one thing that like Mr. Weiss also said, like he said 10 things I hate about pandas, and one thing was that its memory layout and its execution model. So pandas is very eager when it executes, so it doesn't support any optimization. It relies on us to understand how to use it. If we carefully write a pandas code, it can itself be 10 to 20 times faster. But if we don't do it, since it doesn't support any query optimization, that is the major bottleneck in pandas basically. Although there are other problems, but writing a query in an effective way is something that is a key of getting performance out of pandas. So I'll be talking about some tips and see how this kind of thing we can even make pandas better. Then definitely it will come to the picture like how FireDucks can help us to automate those things and all. Okay. So to start with that, I will first have a simple quiz. where I have same implementation written into methods called foo and bar, which is accepting a function, loading the data, removing duplicate, sorting it, and getting the top two of the B columns. So may I know, for example, maybe very soon. Yeah. Maybe I can have something like this. Okay, maybe you can vote. For example, those who are thinking foo is better, maybe you can vote on the foo. Who are thinking bar is better, maybe you can vote on the bar. And let me see the response if you don't mind, please. So probably you can raise your hands if you think foo is the right one that you'd adopt, or if you think the bar is the right one, then please just give a thumbs up so that I can see that how many of you think foo is a better implementation and how many of you think bar. Okay, bar is one. I believe just raising something like this will make it easy for me to count. So, for example, just whoever is thinking foo, just give a thumbs up. Whoever is thinking bar, just give a thumbs up. That will make it easy to count. But anyhow, you can comment also. Bar, okay, bar two, mostly bar, right? In Python 3.3 or 3.13 or earlier. So I think you can think of in the simple Python, earlier version of Python. Yeah. Okay, mostly I can see the perfect 3 and 1, 4. 4 is something that I took. Okay, and yes, as most of you said it correctly, the bar is the better implementation. Probably you guessed it right, but can I have one of you who answered it for the bar, why it is so, before going to the next slide? Curious how much.
Well, you don't have any of the intermediate objects created.
Perfect. Great. May I know who is it? I couldn't see who
This was Ben.
Ben. Okay, thank you, Ben. Yes. So that is the ideal thing. Like when you go for the normal Python one, when we are working on some scalar kind of data, some kind of simple stuff, it's probably fine. But when we are working on the bigger picture, for example, data frame is a collection of the data, right? Series is a collection of the data. And if the data goes higher in size, like it's go larger in size, it's very important to write something in chain such that if we don't need anything, let's make it temporary for Python to get it collected during when it is not needed. For example, as Ben said, if we write something like this, let's say this is my data when I load it, let's say it becomes this data when I remove the duplicates, and the same data is sorted, and then I found top two, and just this is, for example, this is a memory snapshot down the line from 16 GB original data, another 16, 32 GB kind of thing that I may have till the function foo is alive, because all these df t1 t2 t3 is alive and it doesn't know when it will need. So till the time foo is there, all these method, all these instances, all the object have the live instances, so they will not be freed and it will accumulate the memory. So what will happen if you write in chain? When you write in chain, data will be loaded, it has its reference. When we perform drop duplicates, it will have its reference, but when we perform the sort, this reference from the loaded data will be lost and it will be ready for the garbage collection. So Python can efficiently manage this kind of temporary thing. So ideally what we can do, whatever is not needed, we can just let Python handle it, free it. So it can be, first of all, it is much more easy to visualize as well. We can very well understand, okay, this is my data flow, this is my pipeline, I load data, then drop duplicates, this is data pipeline that I follow. So it will make your code much more visually readable. And secondly, it will do a lot of justice with the memory point of view. I'll have a real use case later on this slide where I'll be seeing like how important this kind of writing when we're doing the large scale data in Pandas. Okay, so the next point, there is another one, quiz. So once again, let me take a poll. Okay. So the quiz says, same code. I want to perform sorting my data by B column. DF is my data frame. I want to sort it by B and get the top 5 from the A based on the sorted result. So if you are to write this code, whether you will choose the top one or the bottom one. So maybe you can just show your vote for me to understand how many of you think the top one is the right approach or how many of you think the bottom one is the right approach.
Surav-san, are we are we going to be only interested in the result, or are we also going to be, after this, are we also going to be interested in the original data frame?
Okay, so for example, if you talk about let's make it so in that case, I believe it will be very interesting because yes, I can understand. So in that case, let's say this is something that I have. Okay, so I am just calculating these and returning this. So probably in that case, you can understand that I am only interested in part of the result that I need. It doesn't matter.
Right.
df will be there, df will be input, and I am interested in a part of result. Okay, so now is it better? Understand? For example, let's make it wow. Okay, so to go back to it, I think I already have received a quite few answers, and most of them have said bottom. And yes, the bottom is the right approach. So without taking much more time, because I have spent a few time in these quizzes. So why bottom is better? From the memory point of view and from the performance point of view, as Stephen asked, it is because of this. So for example, when we do our data, we may have many columns. Okay, for example, here in my data, I just used B column and A column, but ideally I may have many columns in my data A to J. But what I'm interested to sort the data by B column and find the kind of A result from it, right? But when I did sorting on the entire data, I end up sorting the entire data. That takes execution time, that takes memory that I don't need. So, and what is a better way to do that? Just create a view of the part of the data that you need. You need A and B part of the data only. Do the same operation and it will reduce your kind of memory and execution time to a great extent. That is kind of optimization, which you call projection push down. And because of this particular thing, this code will work much faster for the larger data. I'll come with an example in later to see how faster it is. Okay, the last one will be another thing, again, related to data flow. So probably I can quickly go through it. So what it tried to do, it tried to join two tables, get a bigger one, and try to filter the category that I'm interested. I'm interested to count the male category to see how many male employees are from which countries. Okay, so this is the data flow that executes. Can any of you identify what is the performance issue if I write this flow? And what if you are about to write this code, what data flow you might be doing in different way? Just a quick thought, like this is might not be good one. Probably we can do it better in a different way. Any messages?
Is it a Cartesian product? Is that the problem?
Okay, it's not a product. A product it depends, like it is merging. So merging is definitely there. But if carefully note, what is my end result I'm interested in? I'm interested to find the how many male employees are from which country, right? But when I'm doing the join, I am not taking into consideration of only the male employee. I'm taking into consideration of the entire employee data set that I have. So during the join, it will create a very large table. For example, if I have billions employee, it will be a billion kind of resultant. Although I'm only interested in the male category, which might be 50% or something, right? Ideally, what is the better way to do that is do the filter operation that will. So my interest is not in the entire data of this, right? So my interest is only in the male category. So I can reduce the number of rows before doing the merge operation. So if I do so, I will have only the data of my interest and I can do the same operation. Output will be same, but this time it will be much faster because merge will be much faster because of the less data that we have this time. So kind of alteration of the filter. Do the filter first, select the target first. In the previous example, I said select the target columns first such that I can reduce the scope of the data in the columnar direction. This example shows before doing operations like merge, group by, etc. If we do the filtration of our rows first, that will reduce the scope of the data, and thereafter I can do the this kind of complex operations. Okay, so that is the benefit. Yes. So with that, so why I talked about this, I'll be talking all this in the notebook, but now let me talk about the FireDucks. That is, as all you have said, it's kind of drop-in replacement for Pandas. What is the different with Pandas? First of all, it comes with the default lazy execution model. So since it is lazy, it can understand your query well. So instead of executing right after you execute, instead of right after you write, dear pandas, do this, pandas will do that. But if you say, dear panda, FireDucks, read the data for me, it will not read right after you say it. It will only read when the result will be needed or something. So I'll be talking about that. So that is why it is lazy. Because of lazy, it can do a lot of just-in-time optimization. And finally, it is multi-threaded. That is again a problem in pandas. So all the operation will be executed in parallel. Because of that, you can experience much faster data analysis. If you're running on the cloud, cloud cost will be reduced to great extent. Carbon dioxide will be emitted less. But the most important point, no code changes. So if you know pandas, you don't need to learn FireDucks. You can install it and use it right after. There is no modification that is needed. And of course, it comes with both lazy and non-lazy model. By default, it is lazy. And not only Pandas application, if you're running a application like scikit-learn, matplotlib, that expect you to pass a data frame that is from the Pandas, you can pass the same data frame that is from the FireDucks, and it can work well with an import hook that we have. I'll be talking about that. So yes, so probably this is a slide that Robert was interested from the very beginning. So first of all, currently FireDucks is for the Linux platform. So if you're running on the Mac or Windows, for Windows, you can try out WSL, but it is for Linux and from Python 3.9 to 3.13. What is a simple change that probably you would like to make? Instead of import pandas, you can just write import fireducks.pandas. That is the sufficient change. But if you have a very large program, for example, you have a program that is importing pandas and your program is importing many other modules, those module internally import pandas. Do you need to change all these import? No. Instead of that, we have a kind of monkey patch kind of thing. So during the execution of program, just provide -name fireducks.pandas. So it will do all the replace by itself. All the import pandas will be automatically replaced by import fireducks.pandas and you'll get the much more speed up. Okay. For the notebook, of course, you can replace by import statement, but on top of import pandas, simply if you add something like load extension fireducks.pandas, it will do the job. So you don't need to like modify rest of the part of the notebook. Same notebook will work fine with FireDucks. Okay, so this is again a simple thing that probably you might like to understand.
Can I get
Yeah.
you to go over that a second? So this load extension I'm not familiar with. This is a Jupyter extension, right?
Yes, this is kind of line magic that Jupyter does have. Not only Jupyter, any IPython kernel, you can use it.
Okay, right. But so I guess the magic of it is that it automatically wherever you see pandas, it swaps in FireDucks pandas. Is that how it works?
Yes. So not only import panda, for example, you're doing import scikit-learn dot something, and scikit-learn internally using import pandas. That pandas will also be FireDucks pandas, such that you can use scikit-learn along with FireDucks. So this is the beauty. Just the idea is you need to use it on top of the notebook. So on top of all the import that probably be using pandas, if you add this, it will
Right.
replace all the pandas with FireDucks pandas.
Very cool.
Okay, yes. So of course, I'll be having a hands-on to understand it in more better. So now notebook part I'll be showing, but for the script one, let me show with the screenshot. So if you see that, okay, I have two queries. I am loading some parquet data. After loading the data, I do kind of analysis. Okay, let me find which is the vehicle body that is mostly involved in the parking violation. So now this, for example, this file is saved with nycdemo.py. And simply when I use it using the Python command, it will be executed by the pandas. Okay. And something like 5.3 seconds it will take when I tried. Now, in order to try it with FireDucks, no, you can definitely make this import fireducks.pandas. But if you don't prefer to modify anything, you can just add this monkey patch -name fireducks.pandas. And you see this evaluation pd.name becomes fireducks.pandas and all the execution, for example, the data loading is faster, the query one is faster, and overall it becomes 0.4 seconds. So if you're running on script, I'll recommend to use this without modification. If you're running on the Jupyter notebook, So that is what I'm coming if you're running on the Jupyter notebook. So simply on top of the Jupyter notebooks, for example, the same code here. This is a original version NOIC demo that I showed in the script. This is the Jupyter notebook. So I used import pandas, and on top of it, so let me have both version such that this is the pandas version. Okay. This is the pandas version. It open in new tab. Okay, so before that, let me paste this link of this notebook such that if you like to try, you can try. Okay, so yeah, so the pandas version, this is the pandas version. Just import pandas and do these steps. So it loads the data. After loading the data, it performs some query, for example, query 1, query 2, query 3, query 4, and the execution time is something like 11 seconds total, whereas these are the individual time for each query, 1 second, 2 seconds, 6 seconds, something. But the same thing, same code, in the FireDucks version, what I did is I just added this extension module. Of course, I installed it using pip. After that, I added this one. Okay. So this time this pd.pand name becomes fireducks.pandas, and rest of the code remains same, and the execution time is 0.7 seconds. With all this query become faster. So ideally no code change, just adding an extension module on top of pandas will help you to get sped up, because it is highly compatible with kind of pandas thing. Yes. So now individual benefit, why it is faster and all. Before going to that, probably I will have a few more time in the slide. So why it is faster? So basically that is an important question. Why it is faster than pandas, and probably why it might be faster than other alternative like polars, DuckDB. So those are the questions that you often ask. So probably I'd like to answer that here. So first of all, it is fast because of three primary reasons. One is the kernel methods. So what are the kernel methods? All the data frame operation, for example, data loading, filtration, sorting, group by, join, everything is written in C++ from scratch in a very careful way. That is ideally different than the pandas implementation. So the kernel itself is very powerful because it ideally takes care of the caches, then also vectorization kind of stuffs. So because of that, the kernels is faster. Second, it does query optimization that is not possible in pandas. So it doesn't matter how you have written. If you've written carefully, fine enough. But if you don't take the careful optimization by yourself, it will do the job for you. That is why it becomes more faster if the query is not written in efficient way. And the most importantly, it uses all the available cores in your system. So it is multi-threaded. Because of this, it is faster. Now to give you an example, what I did, I downloaded some data and tried this piece of code. So load the data, do the sorting on the amount column and calculating the top 10 of the SSN number and saved it to a file. Okay. So when I tried it with pandas, it took around 46 seconds. Now, in order to try it with FireDucks, simply as I said, just add this -m option and it will do the job. So when you try this, ideally it is multi-threaded and it is lazy. By default, multi-threaded, by default lazy. So by default, it falls in this category, lazy and multi-threaded. And the execution time from 46 seconds become 1.5 seconds. Okay, because of the multi-threading and lazy. Now, in order to understand, okay, let's stop both these. Let's not be lazy, let's be eager, and let's be single-threaded and see how it is different than FireDucks. So in order to do that, we have some environment variable, of course. One OMP num thread is a very basic. If you write it 1, so it will be single-threaded. To make it lazy, there is a environment variable called FireDucks flags, and you can add this -- benchmark mode. It will say, don't be lazy, be eager. So when I executed the same piece of code with these two variables, so this time it is the non-lazy mode and single-threaded, and the execution time was something around 35.36 seconds. So still 10 seconds better. Why so? Because all the reading, sorting written carefully in a different way than pandas. That is why even though it is lazy, even though it is even though it is eager, even though it is single-threaded, it might be faster than pandas. Now I added the query optimization. I become single-threaded. Let's use one thread, but let's be lazy. So let's remove this flag. So this time, because of the optimization of this code, FireDucks become 8.28 seconds. And when all of these two, both lazy and multithread is there, it is becoming 1.5. So that is ideally the benefit of each of its layer. By default, it is there. Of course, you can configure and do these experiments. So in order to understand why this lazy becomes so faster than the non-lazy version, let us see this data to understand carefully. What is happening is the data that I used has 44 columns in it. Okay, originally. So when it is eager, it is trying to load all the 44 columns, perform the sorting by the target column, for example, amount columns or something, then select the resultant column, for example, A2 column, just select one column and save it to a file. So that is what it does when it becomes eager. Load all data, sort all data, select the target column and save it to a file. Now, when this is the Pandas that Pandas does, and FireDucks Eager also does the same thing. Now, when I become it's lazy, FireDucks has chance to optimize because it can see, okay, you want to rate, fine. After rating, what do you want to do? You want to perform the sorting on the amount, but after sorting, you only need the SSN column. You don't need any other column from this data. So it can carefully figure out, okay, you only need these two columns, then let me load only these two columns. Let's not load the entire data because you are not anyhow for this particular method to execute. You don't need all the data to be loaded. So it will only load the target columns, sort based on that, select and write it. So because of this kind of optimization that is only possible when you go lazy, FireDucks can become much faster. Okay. So that is ideally one example that shows even though we don't carefully, we can provide a column parameter. In read CSV, there is a column parameter that you can specify to say, don't load entire data, only load these target columns. For example, you can pass columns equals to amount, amount and SSN. So in that case, Pandas will also load only those two columns. But since you didn't specify the target columns, it loads the entire data. But in case of FireDucks, you don't need to specify because it can figure out from the query, rest of the query based on the result, which columns are need. So it can only load that data and do the rest of the operation. Now you can see if I need this data later on, and if I work on different columns, then also because it's compiler, it can compile the entire program and see what are the column in all the query. For example, you write 4 query, and in first query, you need 2 columns. In second query, you need 4 columns. In third query, you need 3 columns. So it can do the intersection that, okay, these are the columns that we need for the entire program. So it will only load those columns. Okay, so it will not load the data every time for every query. Definitely, it is not going to do that. It can figure out what all column I need for the entire program to be executed. It will load those columns and execute. Just to give you a better memory utilization, just give you a faster usage. Now, to talk about it with a real use case, this is a benchmark program from this is a benchmark code from sample code from a benchmark called TPCH, which is a traditional transactional data analysis benchmark. I took the query 3 from here. So ideally this query is written in SQL. So what it try to do, it try to merge 3 tables, do some kind of filter and group by operation. I have translated the same thing in Python in Pandas. And let me show what happened. I simply write it, okay, converted SQL to Pandas and executed it with the simple Python. It took around 203 seconds, okay. But the execution time is still okay. But the memory that it took during the execution of the simple method was around 60 GB. So when this method was executing, the memory was like accumulating and it becomes 60 GB when it took in Pandas. Now I simply put the monkey patch and executed the same query with the -m option, and it becomes 4 seconds, 4.2 seconds to be specific, and the memory becomes 3.3 GB. Now, let's think why it happened. Like what was different in case of Pandas and why FireDucks. Of course, FireDucks is multi-threaded, so multi-threading benefit can be there, but there is huge benefit in memory and other stuff. And that is only because of the lazy part, the optimization part that it took here. So in order to understand that, probably it will be easy. If I go back to the schema of this data that is there in the page 13 of this slide of this PDF, page 13 is not coming. Okay, 13. Yes. So see carefully the schema of this table. I'm dealing with 3 tables: line item, orders, and customer. My line item table having around 16 columns, order is having around 9 columns, and customer is having around 8 columns. So when I try to perform a merge operation, first of all, I load the data, right? I load the data from this 3 table and merge them to create a bigger table. Thereafter, I do filtration of whatever row I need and do the calculation like group by sorting, etc. What happens when you do so? It load the entire customer table, load the entire order table, load the entire line item table, and merge them to create a very big table. And that is the time when the memory become like too packed with information. Probably later on it doesn't, because it will do filtration, it will do group by. Later on it doesn't need, but during the loading and merging, the memory become too high, and that is why pandas become so slow and less effective in terms of memory. Let's do the manual optimization that we talked about in previous slide. What we understand is, if we need a certain column, let's only load that. If we need a certain rows, let's do that filtration first from the previous quizzes, right? So here also, instead of loading the entire parquet, because I identify that out of 8, I need these 2 columns for my customer table. Out of 16, I need these 4 columns for my line item. And from this order out of 9, I need 4 columns for this query. I only loaded these columns using pandas, okay? And thereafter, once the data is loaded, I'm not interested in entire customer, entire order. I'm only interested in customer from the building section, orders which placed before this date, ship which placed after this date. So filter the data. So now I ideally have those data with the target row and column of my need. Now, if I execute the same query this time, you can see FireDucks remains same. Previous query was also 4 point some second, 4.2. It is also 4.8. Memory or consumption is somewhat similar in both cases, but pandas, there is huge change from 2003 seconds to 13 seconds, from 60 GB to 5 GB, because of the optimization that is ideally we can do, like to specify the scope of the data, the scope of the row and column direction of the data. So this is really important when we go in production kind of code and do a real analysis on the larger data. So pandas cannot do it. So if you do it like this way, if you optimize this way, it's very good. But even if you cannot do it, FireDucks is there. It can identify this kind of thing. And this kind of manual optimization is something that is implicit in FireDucks, and it can offer it. Because of that, it can make your code much faster. So, okay, it's just a general overview. Like we have many data frame libraries. We have PySpark, Dask, Modin, DuckDB, Polars. So if I have a simple comparison among these, so I would say Spark, Dask, Modin are for the distributed computing. So if you really need the big data to be clustered in different nodes and do the processing, you may go for that. Modin and Dask somewhat more like familiar with Pandas. So if you're coming from Pandas, Modin, Dask might be for you. If you like the SQL kind of interface, PySpark might be for you. But you may not need a distributed computing always, because it's possible to go better in the single node environment. So for that, we have DuckDB, Polars, and FireDucks. Again, if you need to choose, what you will choose if you like the SQL, because DuckDB is written in SQL interface. If you like SQL, so you may go for the DuckDB because it shows very good performance on the SQL API. But if you are from Pandas background, if you are very familiar with Pandas and don't want to learn a new library, FireDucks will give you a best single node performance and high compatibility with Pandas. So no more code changes and you'll still get better performance. And of course, Polars is there. That is again good in terms of single node computation performance, but you need to understand its API, its syntax. You need to learn the library first. So a learning curve will be there, whereas for FireDucks, knowing pandas is sufficient. So that is some kind of basic comparison from this library. Now, if we talk about some benchmarks, this is the DB benchmark that has lots of query for the join group by operations. And all these data from library have evaluated their kernels for this benchmark. And when I compared with FireDucks, it was coming on top of it. This is the TPC's benchmark. I took an example from here, query 3 in my previous slide to show the memory and execution time. But ideally, it has 22 query. And I compared Polars, DuckDB, FireDucks, all the single node performance library than Pandas, and compare the performance with Pandas. So you can see all of them are quite faster than Pandas for sure. But in average, if you see this particular section, in average, Polars was around 58 times faster. DuckDB was around 109 times faster, whereas FireDucks, the latest version, is around 141 times faster than Pandas because of all the optimization. This optimization supported by this library as well, but many other optimization and other kernel uses make FireDucks more faster. And of course, for some query, for example, query 8, you can see it is even all these, of course, polars, DuckDB, everything is more than 1,000 times faster because of the optimization that is possible in the code level. Yeah. So now, because they are multi-threaded also, so I thought of, okay, I have 22 query. Let's see how it scales when I increase the code. So of course, for Pandas, you can understand it is not multi-threaded. So even if you increase the number of core, it will remain same. But when I scale it for the polars, FireDucks, and DuckDB, I could see at least for this benchmark. I'm not sure how it work for other cases. Polars work pretty well till the core 8 cores, but after that kind of flat scalability was there. Whereas DuckDB and FireDucks work pretty well with the scalability till 32 cores that I tried.
Right. So this is the kind of thing that catches my attention, right? Because
Mhm.
the obvious question to me is, how does this compare to polars, right? So
Mhm.
polars is what gets the press. It's what
Hmm.
gets the attention,
Hmm.
right? So polars is this optimized version, and you can write things more like pure SQL in polars.
Yes.
Um, and it's done in Rust, which is kind of like all the rage these days. Um, and so it looks like one of the key features of FireDucks is
Hmm.
its drop-in compatibility
Hmm.
with Pandas,
Yes.
right?
Yes.
Um, so it looks like you're utilizing the cores better with FireDucks.
Hmm.
Um, and per core uh, you're getting a faster speed up, and it's using the cores more efficiently.
Hmm. Hmm. Yes.
Is
So
that is that a
yes,
correct interpretation?
yes, Robert, this is perfectly correct. So polars, the best thing of polars is something like it does the query optimization and the multi-threading that is ideally not there in Pandas. So, and of course, it has very good like API interface as well. So now if I talk about the difference with FireDucks, so FireDucks does kind of same thing. It is multi-threaded, does optimization that is supported in polars. But one on top of that, it is compatible with FireDucks. So basically this one. So if you are coming from Pandas background, so currently the technology is evolving, right? And there are many data frame libraries coming every day. So if the syntaxes is changing and if they change the interface, so we already are whoever is using Pandas for a longer time are very good, very comfortable with Pandas. So what we thought, let's not make them to rewrite their application. Let's not make them to learn a new library. Rather, they can enjoy their Pandas with the same performance, even better performance than Polars kind of thing, with the optimized kernel optimization and all. So that is ideally make it different. So mostly different is it even for the performance wise, you can find same or better, and compatibility wise, of course, compatible with Pandas. Now,
Hmm.
if you compare with individual kernel, like for the group by how group by in polars and how group by in Pandas, you can definitely look into this benchmark and you can see that it is better in that case also. Kernel wise better. If you want to see the optimization for the query level, because polars does query optimization along with DuckDB, so you can see for this optimization also, because for all this query optimization is something that is working well with, because everything is faster than Pandas, right? At least 10 times faster, all the queries 10 times faster for whatever library you use, because of the optimization, lazy optimization that all of this library support. But on top of it, of course, there are some cases you can see that FireDucks is better, some cases where all the libraries show similar performance, and some cases where it does very good in terms of optimization. So on average, definitely it is showing 141s. So that makes it different. Yes.
Hmm. So DuckDB is in process,
Yes.
um, and uh, I think polars and pandas as well as FireDucks are also in process,
In process,
as
yes.
opposed to using something like
Polars support actually Polars support out of code operation as well. It does support the streaming one. So even if it doesn't fit into a memory, you can do the streaming. That is ideally a feature in Polars. But FireDucks and DuckDB, they do the in-process operation. So if your data can fit into the memory, but now I won't say if your data can fit into the memory, if your data based on your query can fit into the memory. For example, in this case also, the data might be 300 GB or something that might be not there in your memory, but ideally you for this particular query you only need two columns. These two columns definitely can fit in your memory, right? So how you have written your query, that actually matters. Not, it doesn't matter what is the size of your data, it does matter what part of your data you are actually working with. So in that case, definitely it may not happen the entire data will fit when you will execute with DuckDB or Pandas, but for this query only you are using two columns or some columns that can definitely fit into the memory, and it will work good. So that is primarily definitely in process kind of thing that they are in Pandas, sorry, they are in FireDucks and DuckDB. For polars, first by default it is I believe in memory, but you can make kind of stream operation just doing by chunk by chunk.
Hmm.
Any questions till this point, Robert?
I had a
Uh,
question.
Yes, Roddy.
So let's see. Last time you presented with us, that was back in July of last year. I seem to recall there were the multiple that you were touting then was in the 20s, and so now you're up to 140. But I
Yes.
also see that it can be up to 1,000 times.
Yes.
So what is the circumstance in which you get to 1,000x speed
So
up?
basically, in the last July, when I did, there are many optimization that was not supported. For example, this is the optimization that worked pretty well. This kind of the predicate push down operation, like do the filter first. Okay, this is the optimization that was not there, and also loading the target column first. For example, in this query, we can carefully understand. Okay, these are the columns that we need. So let's load these two columns only. Let's not load the entire column. So that is again not supported that time. So that time it used to work on the entire data. So these are the optimization that is supported thereafter. So adding all this optimization. So that time there was not much optimization. So the performance was in terms of multi-threading and a few optimization that was added. Now we have increased the optimizations. So that makes it much faster. So yes, so if I talk about this 1000x and overall 141,
Right.
reason being many optimization has been added in FireDucks compiler level that makes it faster. So if you drop all the optimization by making benchmark mode equals to true or something that I said in this query, I think if you just pause all the optimization in this way, so you will see it will not work that way. It will only give you multi-thread performance. But when you go lazy, you will see all this performance benefit and it will be 141 on average. So this is ideally the end of this presentation. I'll be going to the notebook. So scalability is done. So a quick links for the resources like website and the Twitter page that you might follow for the regular updates. We usually release on every week and we say that this optimization is added, this feature is supported. So probably if you follow the Twitter or LinkedIn page, you can get this update. There is a Slack channel that I would love Robert, Woody, all of you to join. And if you're running something on Pandas, if you need some help, definitely love to
Yeah.
build the community in this way and work together. So that is
Already joined.
Yes.
Yeah, saying I already joined. It's
Oh,
awesome.
you already joined. Okay, thank you, Robert, for that. Okay, so this is the last one. Like, if you love Pandas, stick to it. Use FireDucks for the optimization and enjoy green computing. Now let's go back to the notebook that I was talking so far to give you some kind of important ideology that probably you should understand before using it and or before using it correctly. Okay, so what I'm doing is I'm installing FireDucks first of all. Then, as I said, on top of import pandas and everything, you just add the extension module. So by default, if you don't do it, for example, let's not do it. Let's import it and let's see what is my pandas now. My pd dot name is something, should be okay. I probably have okay, let me restart and execute. Otherwise, it is already executed. Okay. Oh, I executed it all. Okay, restart the session. Yes. Installed. Okay. Imported. Okay. And pandas. Okay. So by default, this is pandas. Now, when you just add this one, so it will become FireDucks pandas automatically, no code change. Rest of the part, wherever PD or some instance related to PD will be there, it will become FireDucks pandas. Now let's see, I'm trying to download the data from the NYC parking side. So this data will have a few rows and few columns. And I would show something that you ideally should follow at least if you benchmark any methods. What should be the good, because FireDucks is lazy, right? Pandas is not lazy. So there is a different way if you want to benchmark individual methods. So that is first thing I want to explain. So for example, I have downloaded the data and I load the data, read parquet, and I want to measure. Let's see how FireDucks does it for me, how fast it is when loading the data. I executed it. It finished within some milliseconds. So it is very hard to believe that this large data is loaded in that fast. Why so? Because
Sir, Stephen has a question in chat. He was
Stephen has a
wondering about the speed up you're claiming. He says, what speed up are you claiming in non-typical or in typical non-benchmark code? Any use cases where it's not good?
I didn't get it correctly. So what speed up usually? Okay, let me check it. Join Slack. Both Slacks. Okay. What speed up are you claiming in typical code? Any use cases where it is not good? Oh, typical. Okay. So non-benchmark typical code, definitely. So Stephen, it will depend. First of all, it will depend on the number of cores that you have. Okay. So if your system has a pretty good number of core, for example, 16, 32 or whatever, then definitely the multi-threaded performance benefit you'll get. But even if you have 2 to 4 cores, you'll get sped up than pandas. That is first thing. Second is how your original query is written. So if you carefully, because I showed you, right, there are 3 layers by which FireDucks offer. So one is efficient kernel, that will always be there because when you use FireDucks kernel will be used. So it is faster than pandas. So that speed up will be there. So that is, you can see for individual. So 2 times, 3 times, 4 times, that will be there for individual kernels. Now, when you go multi-threaded, this will differentiate because the multi-threading will give multi-threaded performance. Okay. Now, if you haven't written your query well, for example, I showed some query where optimization is possible. So that time optimization will be added and it will make it how 100 times, 1000 times. So without any room for optimization, it will highly depend on the efficiency of the kernel and the multi-threading. So if you have 4 cores, you can expect 4 times speed up if you write your code in an efficient way. But if there are room for optimization if you code, then you can expect a very good speed up. For example, as I said, 100 times, 1000 times is also possible. I don't mean speed up over single threaded pandas. I mean compared to say polars or others. Yeah. So in this also, for example, here for if I talk again for this benchmark, if you see, FireDucks was faster than polars around 2.4 times or something. Polars is something around 1 point sometimes. Okay, than Doug. For, in comparison, DuckDB it is 1 point sometimes. In comparison to polars, 2 point sometimes faster than faster in case of FireDucks. Now for the normal queries, so basically if I want to talk about that, so there are some kind of notebooks written by some users who compared some query for pandas, polars and FireDucks at least. So same query, loaded the data, do some group by operation, group by aggregate operation, and if you execute it, for example, the pandas took 10 seconds for this query to run. In case of FireDucks, it took around 0.2 seconds. So of course faster than Pandas. But when the same query with the same lazy execution using polars, can, parquet and all. So polars took around I believe 0.7 okay, 1 seconds. So you can see even in this case also FireDucks is 0.2 whereas polars is 1 seconds. So it is around 4 to 5 times faster, right? So in normal cases you can see this kind of benefit in comparison to polars. And of course now because polars also multi-threaded, FireDucks multi-threaded, both that optimization. So from where the speed up comes, that comes from the kernel. So FireDucks group by is much faster than polars group by and other kernels also. So because of that, sometimes we can exceed the performance of polars. And of course, optimizations.
Do you think that speed up is because it's done in C++ or it's the specific code that was written, which I think
C++
is proprietary, correct?
Okay. Polars is written in Rust, first of all, and we have used it, written it C++. That is ideally a difference, but both these languages are very close to the metal. So ideally, instead of that, the algorithm is very different. Okay, so for example, when you talk about a group by, so these are the area of the research. So all the data frame algorithms, like because data frame algorithms are first of all blazingly parallel. First thing. Secondly, there are n number of different way by which you can implement a particular algorithm. Like when I talk about group by, it depends on how many group I do have. Based on that, I can select my algorithm. So, and we do a lot of our algorithm, our group by, our sort, our filter operation. Filter is very simple. It's just wherever you hit, you just select. So filter, I won't talk about the algorithm thing, but for the sorting, for the group by, for the joining, there are algorithm that makes FireDucks kernel faster than polars. So polars doesn't, I'm not sure how they have implemented, but at least we can say because our implementation group by, we have our patented algorithms that we showed and compared with the normal one. So because of the algorithmic difference, the way of implementation is different. That makes the order of magnitude, like performance order is different, right? And that makes it faster. And it might make some language difference, but since Rust and C++ both are good and close to metal, probably the algorithmic difference is something that makes it faster, I would say.
Okay. So so Polars is open source and FireDucks is still closed source, correct?
Right. So FireDucks is closed, but of course, that is a good question and often heard about it. But ideally, the binary is the binary that comes with the it is under BSD license. So you don't have any kind of restriction to use it for the whatever purpose you may have. That is one thing that I say. Second is the plan for the open source. Usually, ideally, we do have plan. But as you can understand that we are part of NEC, that is a kind of big organization. So there are many processes we need to go through before making something open source. That is a part of NEC.
Yeah,
Like,
that makes total sense.
yeah.
Yeah.
So that is something taking time, and sometimes we need to make them convinced that what is the benefit of making open source and all. So ideally, we are currently stuck on that point, but down the line, definitely we will make it open source. Okay, it may take some more time, but we'll make it open source.
Yeah.
Such that I found that many people are saying, okay, binary is BSD, but still I cannot have a look into it. So I am kind of concerned about how it is implemented. So those who can trust NEC, they can definitely trust, but those who cannot trust, so probably they find it okay, how it is written, whether it is malware or not. So this kind of thing is often discussed, but keeping them aside, so if you can trust on NEC in the library, of course, it is not doing anything malicious, definitely. And binary is BSD, so it can be used for whatever purpose you may have.
Very good. So your slides, are they going to be available?
Yes, I will drop it with Udi later on over the mail. Will that work?
Yeah. Actually, yeah, I mean, you could probably
that
just check
works
them
good.
into the GitHub, right?
Can you repeat, Robert, please?
Yeah, so I went ahead and I checked out the Jupyter notebooks from the GitHub.
Yes.
And that would be like a convenient place to put other things like slides as well, I would think.
Yeah, of course. Basically, we do have, if you see, actually, we have a talk page. Okay, so in FireDucks we have a talk page, and I believe last time Sacramento, yes. So when we
Oh,
did it,
perfect.
we have the slide and video both references there. So probably I'll be adding this talk sometime later. But quickly I can share the slide because this is the slide that I used last time. And this is the video that Odi shared with me the last time.
Because it's slow. It's big.
Anyhow, so this talk page has all these thing kind of whatever talk we do conduct. Some is in Japanese, some is in English. So the slides
Yeah.
and wherever video is available, the video is there. Okay.
So it seems like there's some stuff you get for free. It's just magic. They're just magic optimizations that you don't have to understand or tell it anything to do. But in addition, are there is there like specific things that ways you can tweak it? Is there the ability for the user to tweak their queries as well, or they just let the magic of FireDucks take care of it?
So of course, so there is something that is very good to understand from the use. So one thing that I would highly talk about here is maybe it is for the historical reason. Many people think that NumPy is faster. So I have seen up this practice. For example, people instead of doing something like np dot for example, I have a data frame. Okay, so for example, data frame is a column A, and ideally I want to calculate the mean of that data frame. Okay, so this is the way I can do it. But ideally, probably for the historical reason, I found some of them prefer to do in this way. Okay, they use the NumPy mean for this data frame. So what will happen if you do this for FireDucks? It will definitely work. But since it is not the NumPy job to do the same thing, so FireDucks mean will not be used. So it will be kind of data copy from FireDucks memory to NumPy memory and NumPy to do this kind of job. So if you're relying on NumPy for performance in your application, for the pandas, so I would say not to work on that. So for allow the FireDucks everything to assign to it such that it can do the job. If you are working on the NumPy, it will be unnecessary data copy from FireDucks to NumPy to give it assign the job. So that is something I would like to say if you are adopting it. So don't invoke NumPy explicitly to do the data frame related operation. If it is a data frame related operation, let the data frame to do this. Use the data frame specific way to do that. That is one thing. Second is using of expensive for loops. For example, because whoever using pandas, they have used iter rows kind of loop for doing some operation. So we talk about this thing in our page also, some good practice, bad practice. So if you don't do it, if you do that, usually it will work. Okay, with FireDucks it will work, but we won't be able to make it faster for you. So ideally the tips will be avoid this kind of loop. So the same loop can be written in the data frame specific way. So for example, you want to filter the data where A is greater than 2 and then add the B column. So that thing is possible to do in this data frame specific way in pandas also. So avoid this and do this if you want to get more benefit in normal pandas and of course with FireDucks. In case of pandas, it is slow. In case of pandas, this is much faster. Now, in case of pandas, this is slow, but in case of FireDucks, this will be more slow because of the lazy thing that it will be doing a more overhead. For example, if this code in pandas takes around 1 second, maybe in FireDucks, it can take 8 to 10 seconds because of the overhead involved in the looping this each row of the data. That is what I would say. So one is avoid the loops, avoid the apply wherever possible. And one thing that I would talk like that, don't use NumPy too much. If it is a data frame operation, let the data frame to handle it. Okay. So like just quick one before I believe Robert asked me one question like, is there a way to understand how the optimization happens, that query, and some kind of profiling query? Let me talk and
Right.
some kind of one thing. So three things I'll be talking in. I believe I don't have much time, so let me take 10 more minutes to talk this such that you can use it carefully. So yeah, the last time I said, okay, download the data, read it, and it finished within some seconds. Why so? Because it actually doesn't execute anything because FireDucks is lazy. So it doesn't, it just create an instruction that, okay, you want to read, I will read it whenever you need it. You never use df anywhere in this particular block. So actually it is not evaluated, it is not executed. That is why it seems like it is much faster. Now, when you will write, for example, div.columns or something, you will print, probably it is executed. Okay. When you will do something, it will take much more time. Now, how you can, for example, you want to measure the actual read packet time for FireDucks. What is the way? One way is by forcing it to execute right here. Like in polars, there is .collect method. So that will force the lazy operation to be executed. In FireDucks, if you want to force it, there is a .evaluate method. If you do it, this time the reading operation is actually taking place and it will take some time to read the data. Of course, it will be faster than Pandas, but it will be take, for example, now you can see that 9 seconds is something that it took for loading this entire data. Okay, because this time it actually loads. But if you don't want to put any kind of thing, so there is another thing like go lazy for the entire code. If you go lazy by default, it is sorry, go eager. By default, it was lazy. So just enable this piece of code. It will now become lazy. It will now become eager. So you don't need evaluate. This time it actually eager mode. So it actually loads the data. Okay, so that is something maybe I always say for the user who are benchmarking each API. So if you're benchmarking each method, either go lazy to understand how fast it is, individual API, or use the .evaluate method. But in normal Pandas code, you don't need to make any change. Why so? Because after loading the data, we definitely do some kind of transformation on the data. We do filtration, sorting. Finally, we plot the result. Finally, we save the result. Finally, we print the result. And that transformation will force it to execute. Okay. But if you don't do anything, you just want to see every state, do the evaluate to understand the actual execution time. Otherwise, it will do nothing. Okay. Then second is, I think I don't have much time. So let me take one query, at least the push down, the IO optimization one. Okay, so yeah, so now this is the IO optimization. I execute this method. What it does, it does a load of data, do the group by operation, and after the group by, it perform the count of the summon number column, and finally sort the result and plot the result. Okay, so what I did, I execute this method with both eager and, for example, eager true. When I say eager true, it will be eager method. When I say eager false, it will be lazy. That is by default. If you don't say, it will be lazy by default. Now let's execute both these first and see the execution difference. Okay, so before that, there is one more thing probably you can see here, that is another cell magic, percent FireDucks.profile. What it does is, for example, in case of Pandas, if you want to measure individual execution time for each of this kernel, if you want to measure how long the reading is taking, how long the group back is taking, probably you would keep them in a variable and put a timer before and after and just measure it, right? But in case of FireDucks, you don't need to do it. You just add a line magic on top of a method that you want to profile. It will, during the execution, it will profile all the method. For example, data loading is something taking 168 milliseconds. Group by is taking 176 milliseconds. Without just doing the count timer before and after, by adding the profile, you can inspect the execution time taken for each of the kernel that used in your query for a particular cell execution. Okay. Now, when I execute with the non-eager mode and eager mode, you see the total execution time. When it was lazy, the execution time was 357 milliseconds. And when I execute it with eager mode, it becomes 6,000, around 6.7 seconds, right? Why so? Why that happened? Now, if you want to inspect, okay, during my lazy mode, what was something that helped it to run faster? If you want to understand that, you can add another cell magic, that is underscore verbose. Okay, if you add underscore verbose, it will show you the magic that takes place behind the scene. So
There we go.
okay, so here you wanted to read the data, but if you carefully check the entire query, what you find, I am loading the data, but I'm only interested in two columns from this data, like vehicle body type and the summon number. These are the two columns that I need from this data. Ideally, this is the data that has, I believe, many columns, right? It has so many columns. Okay. So, and of course, loading all this column will take time. Now, what happens when I execute it in lazy mode? You see that you ask the input IR means original representation of the query. So original instruction was reading this, performing a group by on this, and counting on the summon number. Result column should be count, then perform the sort, and then do the slicing like some heading operation, and finally return it. That was the original query. FireDucks will figure out, well, so you are using this column and this column, so let me load only these two columns. I'm not going to load entire column when I'm reading the data. Only these two columns has been loaded. Although it was not specified originally, it will figure out that these are the two columns that it needs. So the optimized version will only load these two columns, and rest of the query will look same here at least. And you will see the benefit of the execution time. When it is lazy, when it was eager, since it is trying to load the entire data, it becomes 6.6 seconds. But when it is lazy, it only load a specific part of the data based on the query. Once again, let me show the profile. So it just loads specific part of the data. So the data loading become only 256 milliseconds. So that is the ideal benefit. Now there are other query also to show you. For example, you can inspect each of this actually. I don't know whether I should take more time, but for each this case, for example, this is an case, you can see what is wrong here. Let me take this one again, at least this one also. So this is kind of projection, push down projection. So I create a random data of many columns and try to perform what? I try to perform the group by on A and calculate the sum of all columns, then only select B and C. Okay. Then I execute it, and let me see when I become lazy, what it does for me. So when it become lazy, it says, okay, so you do the group by on A, perform sum on all column, then selecting the target BC. It's better, since you only need ABC, it's better you create a view of ABC and then do it. So that means select the target column first and do the rest of the operation to give you much faster result. Now, if you do the profiling of both the lazy and non-lazy version, so the lazy version takes around 5 milliseconds, where group by is taking around 2 seconds, and the non-lazy version, the eager version, is taking around 12 milliseconds, where group by is larger because it is trying to aggregate all the columns. So in this way, you can profile each method, you can understand what happens behind the scene. So yeah, so there are many other thing. I believe many you can I created 5 this kind of optimization that you can try out. Okay, this is how the predicate pushed on filtration is pushed before. This is how the projection is happened. This is how the target column is loaded when I go lazy. This is how the common sub expression. For example, in your query you may have some common sub expression. Okay, for example, you want to perform a string column to datetime conversion, but you use the same method 2 times on the same data, some kind of common sub expression. If you do this repeatedly on the same data, Pandas will do it every time, but FireDucks will understand, well, you did it once, so let me reuse it instead of computing more than one time. So some common sub expression will be repeated one time and it will be reused. So these are the optimization that has been added after we talked in the last SacPy meetup. And because of all this, definitely it looks visible in our benchmark. And as I can say, now if you try, definitely, probably you can again suggest, okay, sort of this optimization is also possible. Can you add it? So if you have this kind of suggestion, very welcome. I'd love to have it. And if you have any performance issue also that I tried it, it is slower, how can I do it or something, I'll definitely be helping you. Okay, so with that, probably I can end it here. But if you have any questions, please feel free to ask me.
Yeah, well, that was great. Glad to have you back, Saurav. And when you guys are open sourcing, feel free to think of SacPy as one of the places to present on it. But
Sure,
awesome
sure.
work. Good work to the NEC FireDucks team.
Thank you so much.
Yeah, fantastic.
All right. We will be back next in April. I believe we're going to be presenting a PyTorch project then. But thanks again, Saurav. And we'll see you on, I'll see you on LinkedIn in the meantime.
Sure, definitely. Thank you so much. Thank you all. Have a
Cheers.
good day.